This video contains the solutions to sample exam number 2. So the first section is multiple choice, and the first question is telling us that P of t represents the population of bison in a wildlife preserve, where t is the number of years since the preserve was established, and we want to interpret p prime of 5 equals 10. So the way we want to think about this is that if it was p of 5, that would tell us the actual number of bison in the preserve after 5 years. But p prime of 5 tells us the rate at which that number is changing. So if we look at our choices, A and C aren't talking about rates of change, and so since our statement is a derivative statement, we know those can't be the right answer. And then B and D are just talking about which number does 5 represent and what does 10 represent. Well, t is inside the parentheses, and that's going to stay the same even when we go to the derivative. So 5 is the number of years, and 10 is the rate of change, and so B is the correct answer. Looking ahead to number 2, now we have a cost information. We know that it costs $12,000 to produce 400 skillets. But nothing here talks about a rate of change. And so it's not going to be a statement about marginal cost. So we can eliminate B and D. We're not being told how much the cost is changing. We don't know, for example, how much the 401st electric skillet costs. So the only thing we could do with this information is think about average cost. Now if we take the $12,000 and divide it by the 400 skillets, then what that gives us is $30 per skillet. And that's a statement about average cost. And now the only question is, do we write that as C bar of 30 equals 400 or C bar of 400 equals 30? But 400 is the number of skillets. So again, C of X would tell us the cost of producing X skillets. So C bar of X tells us the average cost of producing X skillets. And so our answer here is A. Looking at number 3, we have that the position of an object in feet east of its starting point is given by S of t. And now we're told v of 5 is negative 10. So remember that v represents velocity. And the number inside the brackets is still going to be time. So this is telling us the velocity, v of 5, is the velocity at t equals 5. In other words, in this case, after 5 minutes. So after 5 minutes, what are we being told about the velocity? Well, the velocity tells us the rate and the direction in which the object is moving. Since the velocity is negative, the object is moving in the negative direction, which in this case means west. So we're being told that after 5 minutes, the object is traveling west at 10 feet per minute, and so that's option D. For number 4, we're talking about differentiability. So which of the following implies that f is not differentiable? Well, if f has a vertical tangent line, that means that the slope is undefined, and so the derivative would not exist. So that means we can eliminate option B, because that would imply that f is not differentiable. Similarly, if f has a hole or a corner, there's no derivative there, so we can eliminate C and D, and so the correct option is A. If f has a horizontal tangent line, that just means that the slope is 0, so f is differentiable, and the derivative there would equal 0. Now for number 5, we're given a bunch of information, and we're defined a function p of x, which is f times g, and we want p prime of 2. Well, if p of x is f times g, then p prime of x, by the product rule, is f prime of x times g of x plus f of x times g prime of x. If we plug in the numbers that we're given, f of 2 equals 5, f prime of 2 equals negative 3, g of 2 equals negative 1, and g prime of 2 equals 6, then in this product rule calculation, what we get is negative 3 times g, which is negative 1, plus f, which is 5, plus g prime, which is 6. Negative 3 times negative 1 is 3, 5 times 6 is 30, 3 plus 30 is 33, and so the correct option is B. Now we're given the same information, but we're given a function c, which is f of g of x. So c prime of x by the chain rule would be f prime of g of x times g prime of x. So if we plug in x equals 2, what we get is f prime of g of 2 times g prime of 2. So g of 2 is negative 1, so this is f prime of negative 1 times g prime of 2. Now we know what g prime of 2 is, but we have no idea what f prime of negative 1 is. And so the correct answer here is that there's not enough information. Now we have a matching problem. We've got 4 functions here at the top and 4 derivatives at the bottom, And so we want to try to match up each function with its derivative. General guidelines to keep in mind is that positive slope means positive derivative. Because remember, the derivative represents the slope. And correspondingly, negative slope corresponds to a negative derivative. So if we look at function a here, what we see is that the slope, not only is it always positive, it's actually a constant positive slope, because a is a line. And so we'd be looking for a derivative that is a constant positive derivative, and so a matches up with Roman numeral 1. For option B, what we see is that the slope is negative to the left of 0. This is negative slope. And then positive slope to the right of 0. So we're looking for a function that is positive for positive values of x and negative for negative values of x. And the only graph that matches that description is graph number 4. Here we have negative values for negative values of x, and here we have positive values for positive values of x. If we look at option C, what we see is that the slope is negative up until some negative value here. Judging by the scale, maybe that's around -2. And then the slope is positive from -2 all the way up to, we might guess, +2. And then the slope is negative again once we pass that point +2. So we're looking for a derivative that is negative for a while, and then positive for a little bit, and then negative again. And that's exactly what we see here in graph number 2. These are negative values, and then the values are positive for a little while, and then they're negative for a little while. And so that would match up with graph C. Now, by process of elimination, we know that graph D has to match up with graph 3, but let's take a look at it and see what we are getting here. So what we see is that in the ends of this function, we have small positive slope. And then in the middle here, the slope is still positive, but it's bigger. Those tangent lines would be getting steeper there in the middle there. So we're looking for a derivative graph that has small positive values on the ends, and then bigger positive values in the middle. And that's exactly what we get in graph number 3. Here we have small positive values on the ends, and then bigger positive values in between, and so this matches up with function D. All right, now here we have some derivative practice problems. So remember that the purpose of these problems is to practice your derivative rules, and so you do not need to simplify your answer. Just be clear which rules you're using and how you're using them. So in this case, we've got 4x squared minus x divided by 8x plus 1, and so we should use the quotient rule, because this is a quotient. So again, saying that you're using the quotient rule rather than just doing it is a good way to get some partial credit, even if something goes wrong in your execution of the rule. So now if we're using the quotient rule, f prime of x is going to be the derivative of the top, which is 8x minus 1, times the bottom function, which is 8x plus 1, minus the top, 4x squared minus x, times the derivative of the bottom, and the derivative of the bottom is 8. And that's all going to be divided by the bottom squared. And again, don't try to simplify that, don't multiply anything out, just leave it exactly like that. For number 8, we're going to need the chain rule. We're thinking of this complicated looking function as u to the 5th power. And again, writing that thought bubble and showing me that you're thinking of it as u to the 5th is a good way to get some partial credit. Now the derivative of u to the 5th is 5 times u to the 4th multiplied by u prime. So that's 5 times 6x cubed plus 8x minus 10 to the 4th power multiplied by the derivative of that inside function. The derivative of 6x cubed is 18x squared, the derivative of 8x is 8, and the derivative of minus 10 is 0. So that's my derivative. Next up, we've got inverse sine of 4x. So again, this is a chain rule problem. We need to think of the inverse sine of 4x as the inverse sine of u. And so the derivative of the inverse sine of u is 1 divided by the square root of 1 minus u squared, and then we have to multiply by u prime. In this case, my u was 4x, so this is 1 divided by 1 minus the quantity 4x squared, multiplied by the derivative of 4x, which is 4. Now for number 10, we've got x times the log base 5 of x. And this is going to be a product rule problem because we've got two functions multiplied together. So my derivative is going to be the derivative of the first function, and the derivative of x is 1, multiplied by the second function, and the second function is log base 5 of x, plus the first function, which is x, multiplied by the derivative of the second function. And the derivative of the log base 5 of x is 1 over x natural log of 5. And again, if you were thinking about simplifying this, we would want to cancel out those x's, but that's not necessary for this type of problem on this exam. Finally, we've got the tangent of 5t, and again, this is a chain rule problem. So think of this as the tangent of u. The derivative of the tangent of u is the secant squared of u, multiplied by u prime. In this case, my u is 5t, and the derivative of 5t is 5. Coming up to the last page now, we've got an application problem. So we're given the population of a city in years after 1950, and we want to find the average rate of growth of the city from 1950 to 2000. So this is actually not a derivative problem. Because we want the average growth rate, what we want is the slope from p of 50 to p of 0. Because 1950 here, that's time 0, and 2000, that's time 50. So what we have to do is plug 50 into our function and plug 0 into our function, and then subtract the results. Now when we plug 50 into this function, we get 407,500. When we plug in 0, we get 80,000. And then we'll subtract those two numbers and divide by 50. When we subtract, we get 327,500 divided by 50. And that's going to give us 6,550. And the units here, since it's population as a function of years, this would be people per year. And in this type of application problem, you would have to include units with your answer whenever possible. Now for 13, we're just asked for the growth rate. Notice that I don't have the word average there. And so whenever I say growth rate without the word average, I mean the instantaneous growth rate. Even if I don't use the word instantaneous, we're talking here about the derivative. So what we want is p prime of 60, because if we're counting years starting at 1950, 2010 is 60 years later. So before we can do p prime of 60, we need to find a formula for p prime of t. So we take the derivative, we get negative 1.7 times 3t squared plus 72 times 2t plus 7200. So that's the formula for our derivative, and now we just have to plug in 60. So negative 1.7 times 3 times 60 squared plus 72 times 2 times 60 plus 7200. And when we work all that out, we get negative 2520. And again, the units here would be people per year. And that negative number just tells us that the population is declining at this point, so it's totally reasonable for us to get a negative answer here. All right, next up, we want to find the equation of a tangent line to this function at x equals 3. So what we're going to do is find a formula for the derivative, plug into the derivative, that will give us the slope of the tangent line, and then we'll use our point slope form to find the equation of the tangent line. So if y equals x squared plus 2x plus 10 all inside a square root, to find the derivative, we're going to rewrite that as x squared plus 2x plus 10 all raised to the 1/2 power. Y prime, we'll use the chain rule. We get 1/2 times x squared plus 2x plus 10 to the negative 1/2, multiplied by the derivative of the inside stuff, which is 2x plus 2. So now we plug in 3. We get y prime of 3. That's going to be 1/2 3 squared plus 2 times 3 plus 10 to the negative 1/2 times 2 times 3 plus 2. And when we work all that out, we get 4/5. So 4/5 is the slope of our tangent line. And to find the equation of our tangent line, we're also going to need to actually plug x equals 3 into this function. So we're also going to need y of 3, which will be the square root of 3 squared plus 2 times 3 plus 10, and that works out to be 5. So plugging into our point slope form, we have y minus y0 equals m x minus x0. Our y0 is 5, our m is 4/5, our x0 is 3, And when we solve that for y and work it all out, we get 4/5 plus 13/15. 13/5, sorry, 13/5. Y equals 4/5 x plus 13/5. All right, next up we've got an implicit differentiation problem. So cosine of y equals x plus y. We want to find an expression for dy dx. Since we can't solve this for y, what we're going to do is take the derivative of both sides. When we take the derivative of cosine y, we get negative the sine of y times dy dx by the chain rule. On the other side, derivative of x is 1, and the derivative of y is dy dx. So what we want to do is get everything with the dy dx on the same side of the equation. So we're going to subtract dy dx from both sides. So we get minus the sine of y dy dx minus dy dx equals 1. Factor out the dy dx, so we get negative the sine of y minus 1 times dy dx. And then finally, divide both sides by minus the sine of x minus 1. So our answer would be 1 over negative sine of y minus 1. Now finally, we need to take the derivative of an expression that looks like x to the sine of x. Now remember that none of our basic rules work here. If it was x to a power that was a constant, we could use the power rule. If it was a number, a constant raised to a power that was a function, we could use our rule for exponential functions together with the chain rule. But because both the base and the exponent are functions, then we need to use our different technique. So the technique here is to think of x as e to the natural log of x. That's true just based on properties of exponents. So our f of x here, rather than thinking of it as x to the sine of x, we think of it as e to the natural log of x, all raised to the sine of x. And the advantage of doing that is now our function looks like e to the natural log of x times the sine of x, and now we can just use the chain rule. So f prime, if we think of this as e to the u, f prime will be e to the ln of x times the sine of x. And that's going to be multiplied by the derivative of u, the derivative of natural log times sine. That's going to be a product rule problem. So we get 1 over x times the sine of x plus ln of x times the derivative of sine of x, which is cosine x. And then we're essentially done, except that we really should rewrite this, since this first term here, e to the ln x sine x, that really is just the original function, x to the sine of x. And so here's one place where we really should rewrite this in a easier to understand form. So we can leave all the rest of this stuff, but we should rewrite this in terms of the original function. And so that would be the answer I'd be looking for. All right, that's it for the sample exam. Hopefully this helped. Again, as always, if something wasn't on here, that doesn't mean that it couldn't be on the real exam, so make sure that you study everything, make sure you have all your derivative formulas memorized, but hopefully this gives you an idea of the types of problems and the types of topics that you'll see on this next exam.